In this video of electrostatics, you are going to learn about Coulomb's law. Coulomb's law is based on experimental study involving charges separated by certain distance. It was observed that the electric force between these two charges is inversely proportional to the square of the distance between them. Simply means that higher the distance, lesser will be the force of attraction or repulsion. Also, it was found that the electric force is directly proportional to the product of magnitude of the charges. So, higher the value of charge, higher will be the force. This electric force was attractive for unlike charges and repulsive for like charges. Removing the proportionality, we get F equals to K Q1 Q2 by R square in terms of magnitude, where K is Coulomb's constant. Coulomb's constant K is given by 1 upon 4 pi epsilon naught into epsilon R, where epsilon naught is permittivity of free space and epsilon R is relative permittivity of the medium. Permittivity itself is the ability of the substance to store electrical energy in an electrical field. So, higher the permittivity, lesser will be the value of K and hence lesser will be the force. In general cases for air and vacuum, epsilon R will be equals to 1. So, we get K equals to 1 upon 4 pi epsilon naught. Experimental value for epsilon naught is 8.85 into 10 raised to minus 12 farad per meter. Substituting it and simplifying, we get K equals to 9 into 10 raised to 9 Newton meter square per Coulomb square. Now, let us learn about Coulomb's law in vector form. Consider two charges Q1 and Q2 situated at a distance R1 and R2 from the origin. The distance between Q1 and Q2 is R. Assuming they are like charges, they exert repulsive forces on each other having magnitude F12 and F21, where F12 is the force exerted on Q1 by Q2 and F21 is the force exerted on Q2 by Q1. Mathematically, F12 will be equals to K Q1 Q2 by R square into R cap. So, in vector form, F12 will be given by this entire term, where the first term in this equation gives the magnitude of the force exerted and the second term gives the unit vector in the direction of F12. Let us now solve a numerical to understand how these forces work. Two objects whose charges are +1 and -1 are separated by 1 kilometer. Compared to 1 kilometer, the sizes of the objects are small. Find the magnitude of attractive force that either charge exerts on the other. Now, you are given charges Q1 and Q2 as +1 and -1 Coulomb. The distance R is given as 1 kilometer. So, we use F equals to K Q1 Q2 by R square. Substituting the values and simplifying, we get the force equals to 9 into 10 raised to 3 Newton. This force is equal to weight of a 1-ton truck. Such forces are exerted in extreme cases such as a lightning bolt. Here, charges as high as 25 Coulomb are transferred. But for experimental basis, the magnitude of charges used is of few microcoulombs. You can also find me on my Facebook page. I am posting solved numericals from H.C. Verma and similar books for mechanics. Subscribe to the channel if you haven't already and tune in for more videos next week.